and 21.
This is the ultrasonic sensor that we use for Arduino that travels from here to the wall, and coming back will take some time.
From the right, ground is connected using black wire to ground. This sense because it will give you a 0 or incorrect reading. This course is based on SunFounder 3-in-1 Arduino kit sold on Amazon. Everything that you learn in this course is included in this kit. The course comes with tons of components and projects, all with instruction and video for smart car and other projects that you can use for school or home automation. You can purchase it from sunfounder.com. The kit also comes with full documentation, code download, learning projects with full explanation, wiring diagram, and the code that you can download. The link to purchase the kit and documentation is below the video in the description. Welcome to Arduino course by Robojax.
This is the ultrasonic sensor that we use for Arduino. This is one of the most famous component that is used for measuring the distance, and it's being used in cars to avoid obstacles. It's being used in robotic arm. These are two speaker type modules. So this is a transmitter that acts as a speaker, and it transmits ultrasonic. Ultrasonic means this is above the hearing frequency of human, which is above 25 kilohertz. So this will be around 40 kilohertz. So this transmits, and this piece acts like a receiver. They put R here and it receives it. Here is how it operates. I've drawn this diagram to illustrate it. This is the ultrasonic sensor, and this is a transmitter, usually shown with TX. This sends ultrasonic wave, and when it goes and hits, for example, this object, this is a wall, it hits and returns or bounces back. The signal that travels from here to the wall and coming back will take some time, and the phase of the signal at this point is compared with the phase at this point, and we will see what is the delay. And by calculating the delay of the phase, because we know the speed of sound, we can determine the distance. So with Arduino, we can get the distance of the object from this device, from this point. And in one of the applications would be that you may build a smart car and install this at the front of the smart car and program your Arduino that whenever this approaches to an object, for example, when it reaches 30 centimeters, you can stop the car. Or when it reaches a certain distance, you can use the steering and turn the car left or right to another direction until it finds a clear path and then proceeds. So this can be used in so many ways. The module has four pins. This is a VCC, will be connected to 5 volts. This is ground, and then we have Treg and Echo. And the chips that are used here, with conjunction to the calculation from Arduino, the proper wave signal is sent here, and the wave phase is measured, and when it receives the signal, compares it, and from the delay it calculates, and the value will be available within the Arduino.
I've drawn this using FritzSync. This is a free software. So from the right, ground is connected using black wire to ground, and here I've used this black wire connected here to ground. Then we have brown wire and red wire. Echo is connected to 11 and trigger is to 12. And here red and brown are connected to 11 and 12. And then the orange, the last one, is connected to 5 volts, and the orange is connected here to 5 volts.
In order to use this module, you need extra set of codes that have been written specifically for this device to work, and it's called library. So we are going to download the library plus some code that is within the Arduino IDE. Together they will do the calculation for us. So let's first get the library, and then I'm going to explain the code for this. First, let's go to this address that I will provide you, robojax.com, and you will see this page and download the library. This is the official library that is there, but this is a direct link. Click and then save it somewhere, let's say in downloads. Then go to Sketch, include library, and click Add Zip Library. From here, point it to your downloads, and that is the ultrasonic library. Once you click and open, it will be included in your library.
Now let's open the example from the library. Click on File, Examples, and scroll down until you see New Ping, and click here Ping Example, and that's the code. This line we are including the library using include, and this line we are defining pin 12 for trigger pin and 11 for echo pin, and the maximum distance, because it will give you a 0 or incorrect reading, we have to set the limit for the amount of maximum 200 that we want, or lower that you need. In this case, let's put it to 200, that is centimeter, and then we get the library class and we create an object and we pass these variables here, the first one, the second one, and the third one, to this object. So the sensor is initialized, and then we initialize the serial monitor with 9600 because we are used to that. And then inside the loop we have 50 millisecond delay for the servo, for the ultrasonic sensor to read. This is just printing the ping text. Actual reading is in here. Sonar ping centimeter, it will give you the distance, and we print after that, we print the centimeter after it. And here is a demonstration, because I have here a box. I'm putting it in a certain distance, exactly by the end of this ruler, and we have to make sure that this side or the wires does not touch the metal. So I'm going to put it this way and read the distance. As you can see, right now it's at 17 centimeter, and we are reading 17. That's amazing. So let's move it. 20 centimeter. It goes between 20 and 21. 26 centimeter. As you can see, it's very exact. Let me point it to the wall. And ceiling. You see, when it is 200, it gives 0. So we have to, I'm pointing it now to my computer monitor. And now this is, let's point it down 14 centimeter and go down 7, 5, 2. So after 2 centimeters, it cannot read. Keep that in mind. 40. So as you can see, this works perfectly.